Okay, part 2 of week 8 and 9. We're going to start with number 12. Number 12, I said to try that one before the last video ended. It's very similar. Same thing, find the min and max. So the absolute min and max. So you need the derivative. Change back to black. All right, there we go. All right, so you have 6x squared. Cursor. All right, here we go. 6x squared plus 6x minus 12, set it equal to 0, factor out a 6. All right, so this one we're going to get two critical numbers, it looks like. So we're going to have one at -2 and one at 1. So now remember, be careful. You want to check to make sure that the critical numbers, so these are your critical numbers, are in this interval. So this one here isn't in your interval. So you don't want to test this one. Don't test this one. It's not in your interval. So this one you're going to test -2. You're going to test -3, and you're going to test 0 to get your highs and lows. So obviously when you plug in 0, you get 0. That one was pretty easy. So the next one, when you plug in -2, so when you plug in these numbers, it's a little more difficult to plug in, but not impossible. So I just want to get my sheet and plug them in. Do the math in my head. So when you plug these in, you get 9 for -3, and you get 20 for -2. And we got 0. So this one is going to be the absolute min. It's the lowest one. And then the 20 is going to be the absolute max. Okay, so you got that one. Okay, so now what we have to do now is we're going to do the one up above, since it's dealing with x's, and then we'll do the trig one last. The one up above just says relative, so you can see that one there doesn't have any endpoints to test. So this will just be the top of the hill and the bottom of the hill. It may not be the absolute maximum or absolute minimum. It might be, but in this case, there's no endpoints to test. So this one, we're just going to get our critical numbers and test our critical numbers. So if it ever says relative, you just get the critical numbers and you just test them. You don't have to test anything else. So the reason I put this one is to do the quotient rule, to remind you of that one. So y prime is the bottom times the derivative of the top, which is 1, minus top guy, derivative of the bottom is 2x plus 2. Over the bottom guy squared. Okay? So now when you simplify, you multiply all this out. That's the only way you can do it. And then multiply the top out. Make sure you move this negative sign through all of them. So you're going to have a -4x here when you move the negative sign. And then you're going to have a -2 there. All over the bottom guy squared. So this is the first time we have a bottom in our derivative. So y prime, when you're all done, should be -x squared. And then you should have a -2x. And then the 2's cancel out. And then the bottom is that guy squared. Right? Squared plus 2x squared. So now, to find your critical numbers, what you technically do is you set the bottom equal to 0, because that's where the derivative is undefined, where the derivative would be 0 on the bottom. But there's no numbers. There's no critical numbers on the bottom. This one you can't make 0. But the top you can make 0 to get some critical numbers. So we'll kind of just write that off to the side there. So when you do that, you get two critical numbers. You get x is 0, and then the other one you get is x is -2. So remember, you always put these critical numbers back in the original to figure out what the y value is. And I did that on my paper. So when you plug in 0, you get a half. And then when you plug in -2, evidently you get -1/2. So this guy is the relative max. It's the highest one. This guy is the relative min because it's the lowest one. So that's how you do relative. You only have to worry about the critical numbers, whatever makes 0, depending on what kind of derivative you get. So now the last one we're going to do is a trig one, which is the one up above here. So trig ones work the same way that regular one does. So this is absolute, so it has some endpoints here. So what you do is you find the derivative. So the derivative of tangent is secant squared, and then the derivative of the angle is 1. So you do the same thing whether it's a trig one or one with x's, is you set the derivative equal to 0. Now this one, what we're going to do is we're going to make it like this. We're going to make it cosine squared. So secant squared is 1 over cosine squared. So now this one will never be 0 on the top because it's always going to be 1, but it is going to be 0 on the bottom. So cosine is 0 at a lot of different places. It's 0 at pi over 2, at 3 pi over 2, at negative pi over 2, at negative 3 pi over 2, so forth and so on. So now you have to look, are any of these critical numbers, and they keep going on forever. So this is where the derivative is undefined, which are critical numbers. Okay, that's that Dunce's cap. Could be kind of an asymptote in this case possibly. But so what you do then is you check them to see if any of them are up there. And actually, none of them are in that range there. So this one, you're only going to test the endpoints, which is negative pi over 3. And the other one is pi over 4. And you're going to check these in the original. So when you do that, you're actually doing the tangent of negative pi over 3. I just kind of wrote it out. And the tangent of 45 degrees, which is pi over 4. So the y guy on the right here, the tangent of 45 degrees is 1. That's pretty easy. But you may have some trouble with the tangent of negative 60 or the tangent of 300 degrees. So if you just kind of draw a little triangle here, there's 60. So it's 1, root 3, and 2. This is just the unit circle. So tangent of 60 or negative 60, doesn't really matter, is root 3 over 1, which is root 3. But in the fourth quadrant where this is, if you remember, all students take calculus, it's actually a negative number. Okay, it's actually negative. So this one here will be the absolute min, and then this one, since it has a y of equal to 1, it'll be the absolute max. So that's how you do min and max, whether it's an absolute min and max or whether it's a relative. So absolute, you check the endpoints and check any critical numbers. Relative, you only check the critical numbers. There are no endpoints. Right? So that's kind of an application of derivatives. So now what we're doing, before we kind of get to the main thing, which will carry us through for a week or two, is we're going to talk about the mean value theorem. What the mean value theorem says is, and what we're going to try and do is, we're going to figure out the slope of a secant line. So what we're going to have is we're going to have 2 points. Okay, I have to give you these points. So what I did here is, here's the x values. These are x values. So when x is a half, we're going to figure out the y. When x is 2, we're also going to figure out the y. Right? So when you plug in a half into the function here, you get a half plus 1 over half, which is 2. So the y guy is actually 2.5. Similarly, when you plug in 2 into the function, you get 2 plus 1 over 2 is the half. So you also get 2.5. So these points are going to make up our secant line. So these are our secant line. Okay, they're our secant line. They're going to be the points that make up our secant line. So what we're going to do is we're going to figure out the slope of the secant line. Slope of secant line. So the slope of 2 points is you just subtract them, and then over the x's and you subtract them. So y2 is 2.5 minus minus y1 is also 2.5. And then x2 is 2, and then x1 is 1/2. So you get 0 over 1.5, which is 0. Okay? So the slope of our secant line is 0. So now what we're going to do is we're going to figure out a point on the tangent line that gives us a slope of this case 0. So now we're going to worry about our tangent line. I don't know if I have enough room here. Hopefully I have enough room. Yes, I do. All right. So now let's figure out our tangent line. Let's figure out our slope formula for a tangent line. So probably should put tangent line. Change that. All right. So there we go. That's working. So let's figure out our tangent line. All right, so you're going to figure out y prime. So here's our y, guys. So the derivative of x is 1, and then the derivative of x to the -1 is negative x to the -2. Right, so this is our tangent line formula, which is our slope formula. This is our slope formula. So what we're trying to do is we're trying to figure out what point has a slope of 0. So you're going to set 0 equal to your tangent line. So I just changed that to 1 over x squared. So in this case, whatever slope you get for the secant line, whatever this number is, in this case it's 0, you set it equal to your tangent line, and then you're going to figure out the x value that gives you a slope of 0. So you subtract 1, and you get this. And then you get 1 equals 1 over x squared. So in this case, the only number that works for x, well, there's actually 2 of them, in this case, is x equals 1, and actually x equals -1. So at either of these numbers, you're going to have a slope of 0. So now we figured out, if you kind of go back to the picture here, this tangent line is going to have at x equals 1, so this is kind of x equals 1, it's going to have a slope of the tangent line of 0, which is the same as the secant line. So it's actually going to be 1 or -1. But in the interval, we're only looking at x's between 1/2 and 2. So that's why the book answer would be 1 in this case. But actually it occurs at 2 different places. It occurs at 1 and -1. Okay? So, but this is the only answer. So only answer in the range. Okay, but -1's not necessarily wrong. Okay? All right, so that's one other application called the mean value theorem. It's kind of a popular thing in calculus. So now, what we're going to talk about is the first derivative test a little bit. So if you remember, derivative means slope. So what we're going to do is we're going to figure out this curve and where it has an increasing slope and a decreasing slope. So first what we're going to do is identify the critical numbers, just like we did before. So you have to figure out y prime. So 3x squared minus 12. And then just like you did before, you set it equal to 0, and you factor. And when you set it equal to 0, you have to factor this again. All right? So this one, our critical numbers are 2 and -2. Right? So now what we're going to do is we're going to make a little number line. Right? So we know at 2 our slope is 0. And we know at -2 our slope is also 0. So wherever the slope is 0, before or after that x value, the slope is it could possibly change to whether it's increasing or decreasing. So the way you get your pluses and minuses kind of on your number line is you substitute numbers back in the derivative, not into the original, to figure out if it's increasing or decreasing. So we're going to put some answers here in a minute. So if you put numbers into your slope formula, because remember, this is your slope formula. Okay, that's your slope formula. That'll determine, you only care about the sign of it. You don't care about what kind of number it is. You just care about whether it's positive or negative. So if you put in a number like 3 into your slope formula, you get a positive number. So you're putting this into your slope formula. If you put a number in between -2 and 2, like 0, so if you put in 0 into your slope formula, you get a negative number. If you put in -3, something on this range, into your slope formula, you actually get a positive answer. So that means the slope is positive. So this thing is increasing from -infinity, -2, union, and then from 2 to infinity. That's where it's going to be increasing. And then decreasing is going to be between -2 and 2. You never include these where the slope is 0, because when the slope is 0, that means it's not increasing or decreasing. So what this function kind of looks like, just kind of based on the pattern of the pluses and minuses, if the slope is positive, what's going to happen is it's going to go up, and then at -2, it's going to hit a high point where the slope is 0, and then it's going to go down, and then at +2, it's going to hit a slope of 0, and then it's going to go back up. So this in general is what the function is going to look like. Positive slope to -2, and then negative slope to +2, and it's got to go back down to 0, because here's your tangent lines, right? They're all at 0. And then it's going to go back up, which is a positive slope. So that's how you do increasing and decreasing. So you find your critical numbers, and then you do the intervals of increasing and decreasing. So for this one here, we're going to do the sine. So you do first guy, x squared minus 3. Derivative of the second guy is e to the x, plus second guy, e to the x, times the derivative of the first guy is 2x. Set it equal to 0. So when you do that, what you can actually do, we'll kind of multiply this out, and then we'll factor it and show you kind of how it works. So it's x squared e to the x minus 3 e to the x plus 2x e to the x. So what you can actually do is you can actually factor e to the x out. You get x squared, and then I'm just going to put this first, plus 2x, and then on the end I'm going to put the minus 3. So then last but not least, you can factor it again, x plus 3, x minus 1. So your critical numbers here are, well, let's kind of go back a little bit. This thing here, you might be wondering, okay, is this thing ever equal to 0? Because this is one of the answers you should possibly have. And then, you know, obviously the other ones are this one, and then the other one is x minus 1 equals 0. So you can see I'm kind of running into the next problem, but this guy here, one of the critical numbers is -3, and the other one is 1. This thing here will never equal 0, so this one doesn't have a solution. E to the x is always positive. It's never equal to 0. It's always some type of positive number. So this one, when you do your number line, you're going to have two numbers on it. You're going to have 1, and you're going to have -3. Okay, and then we'll do our increasing and decreasing down below, and then I'll have to erase it. So this one, remember, you plug it in the derivative. So I might just use this formula right here, down here at the bottom. E to the x is, no matter what x value you plug in into this derivative, e to the x is always positive. So you only have to worry about the signs of these other guys. So when you plug in like 2 into here, you get a positive times a positive, which is a positive. If you plug in 0 into the function, into the derivative, I should say, not the function, into the derivative, you get, if you plug in 0, you get a positive times a negative, which is a negative. And then if you plug in -4, you get a negative times a negative, which is a positive. So even if you plug a negative number in here for e, it's e to like -4, which which is 1 over e to the fourth, which is still a positive number. It's small, but it still is positive. So then when you get your increasing and decreasing, so increasing is going to be similar to last time, and then decreasing. So the decreasing would be from -3 to 1, and then your increasing is negative infinity to -3, union, and then 1 to infinity would be your increasing and decreasing. All right? So let's do one more, and then we'll stop the video. And then the last part of this is a whole chart, and we're going to look at the second derivative test. So this is all the first derivative test, which has to do with slope. Okay? All right, so this one is a trig one. So let me kind of erase some of this. All right, so when you do the derivative of this one, you might want to write this cosine x, and then the whole thing is squared like that. Okay? All right, so here we go. Y prime. The derivative -2 comes along, and the derivative of cosine is negative sine. So this actually turns to a positive. Right? Derivative of cosine is negative sine, -2 comes along, so they cancel each other out. And then the derivative of this, 2, cosine x goes to the first power, so 2 times 1 is 2, cosine goes to the first, and then the derivative of cosine is negative sine. Right? So now what we're going to do is, you can see both of these have a sign. So what we're going to do is set it equal to 0. And then actually we're going to factor a 2 out and a sign. We'll do that at the same time. So when you take a 2 sign and a 2 sign, you have a 1 left. Now this is going to turn positive because we have a negative times a negative, which is a positive. And then we took a 2 sign out. So the only thing left is a cosine here. So then what you do is you set each of these equal to 0. So that's that one. So divide by 2, and you still get 0. So sine is 0, and 0, and pi, 2 pi, and -pi, so forth and so on. This one here, we have to set this one equal to 0. So this one, we're going to subtract 1. So we're trying to figure out where cosine is -1. So this value, that value here, these critical numbers, is pi, negative pi. So you can see that the critical numbers are very similar, but you only want the ones between negative pi and pi. So whenever you do a trig one like this, there'll be limitations. So this one only goes out to pi and only goes down to negative pi. It doesn't go to infinity. So you look for any numbers in between there. In this case, 0 is between there. That's the only number in between there. So then what you can do is, if you have trouble, this is the derivative here. This formula right there is the derivative. You would plug like pi over 2 in. Pi over 2, like the sine of pi over 2 is 0. And then the cosine of pi over 2, the sine of pi over 2 is 1, excuse me. And then the cosine of pi over 2 is 0. So you can see if you plug pi over 2 into the derivative, you actually get a positive number. And if you sub negative pi over 2 into the derivative here, you actually get a negative number. So that might be difficult for some of you if you don't maybe have a calculator or you're not good at subbing in pi over 2. So this one, for increasing and decreasing, you only go down to pi, or up to pi and down to negative pi. So this one is increasing from 0 to pi, and then decreasing from negative pi to 0. It doesn't go to infinity. Trig ones will never go to infinity because trig ones go on forever, and they go up and down, up and down. So it increases and decreases for infinity. It just goes up and down the whole time. So you're going to have limitations whenever you do the trig ones. Okay, so I think we're going to have 2 more videos probably in this thing. The next one is filling out this chart and talking about an inflection point. So we talked about min and max. We talked about increasing and decreasing. So inflection points and concave up and down have to do with a derivative. The second derivative, which we'll talk about in the next video.